Welcome to Manish's Tech and Science Insights. Today, we're unraveling the fascinating history of calculus and the legendary contributions of Isaac Newton and Gottfried Wilhelm Leibniz. Who really invented calculus? Let's dive in and find out. Imagine a world without calculus. We couldn't understand the motion of the planets. Building bridges and skyscrapers would be impossible. Even your smartphone wouldn't exist. Calculus is the language of the universe. It's the mathematics of change and motion. Two brilliant minds, Isaac Newton and Gottfried Wilhelm Leibniz, brought this powerful tool into existence. Their independent discoveries, separated by time and geography, sparked a controversy that captivated the scientific world. Who was the true inventor of calculus? Let's travel back to the 17th century and unravel the mystery of calculus, a story of genius, rivalry, and the pursuit of knowledge. The 17th century in Europe was a time of intellectual upheaval. The Renaissance had rekindled the spirit of inquiry. Scientists were challenging old ideas. They were searching for new ways to understand the world. There was a thirst for knowledge, a desire to unlock the secrets of nature. Thinkers like Galileo Galilei and Johannes Kepler were making groundbreaking discoveries in astronomy and physics. René Descartes, with his revolutionary coordinate system, paved the way for the visualization of mathematical concepts. This was the backdrop against which calculus emerged. It was a time ripe for a new kind of mathematics, one that could tackle the complex problems of motion, change, and infinity. Isaac Newton, an English physicist and mathematician, is a towering figure in the history of science. In the 1660s, he developed his version of calculus, which he called the method of Fluxions. Newton's work was driven by his desire to understand the laws of motion and gravity. He imagined objects moving continuously and changing infinitesimally. Newton saw calculus as a tool to describe the physical world. He used it to explain the orbits of planets, the tides, and the motion of projectiles. His masterpiece, the laid out his laws of motion and universal gravitation, forever changing our understanding of the universe. Section 4. Leibniz takes the stage. Across the English Channel in Germany, Gottfried Wilhelm Leibniz was also developing his own version of calculus. Leibniz, a polymath with expertise in philosophy, law, and mathematics, arrived at his version independently of Newton. He began his work in the 1670s, focusing on finding the areas under curves and solving tangent problems. Leibniz's approach was more focused on finding a clear and concise notation for calculus. He introduced the symbols we still use today, such as dx for an infinitesimal change in x and the integral sign for summation. Leibniz's notation made calculus more accessible. It allowed mathematicians to communicate their ideas more effectively. His work laid the foundation for the development of calculus as a distinct branch of mathematics. Section 5. A battle of giants at the calculus controversy. The question of who invented calculus first sparked a bitter dispute between Newton and Leibniz, their supporters, and even their nations. Both mathematicians had developed their versions independently, but the timing of their publications and correspondence led to accusations of plagiarism. The controversy raged for years, dividing the mathematical community. It hindered the exchange of ideas and slowed the progress of calculus in Britain. The dispute was never fully resolved during their lifetimes. Section 6. The legacy of calculus. Today, Newton and Leibniz are both recognized for their contributions to the invention of calculus. Their work revolutionized mathematics and science. Calculus has become an indispensable tool in physics, engineering, economics, and countless other fields. It allows us to understand and model complex systems, from the behavior of subatomic particles to the evolution of galaxies. The legacy of Newton and Leibniz lives on in every bridge we cross, every skyscraper we build, and every scientific discovery we make. Their story reminds us that the pursuit of knowledge can lead to unexpected discoveries. It highlights the power of human ingenuity to unravel the mysteries of the universe